Welcome to the channel Physics by IITians. We are back with another interview question, and this question was asked in IIT Bhubaneswar PhD interview. The question is, if a radiation with energy 1.1 mega electron volt enters a particle detection chamber, then whether there will be any occurrence of pair production or not. So you have a high electromagnetic radiation, if you have a high electromagnetic radiation now with energy 1.1 mega electron volt, and it is entering into a particle detection chamber, and whether there will be any generation of pair production or not. We should understand first what is pair production, what are the criteria of pair production to occur, and then we shall know some more basics about pair production. So let's start today's video. What is pair production? Pair production is when high frequency electromagnetic radiation passes through a foil, individual photons of this radiation disappear by producing a pair of particles consisting of an electron and a positron. So, from photon you are getting a pair of electron and positron, and this process is called pair production process. Now, this is the schematic diagram of pair production process. Look here, the incident photon, that is of energy h nu, and it is interacting with a nucleus and it is generating a pair of two particles. One is positron and another one is electron. We should ask some questions and we should try to find out its answer. The first question is, can it occur in empty space? So, pair production is possible in empty space or not? No, pair production is not possible in empty space. Why? Due to charge conservation, due to charge, momentum and energy conservation, pair production cannot occur in empty space. Now, when does it occur? This process, pair production to occur, that is photon to generate electron and positron pair, the photon must interact with an external field. Which kind of field? Such as Coulomb field of an atomic nucleus to absorb some of its momentum. So, it needs presence of nucleus for its momentum conservation, and then only this kind of process occur, because for any process to occur we have to follow, or we need to obey some basic fundamental conservation laws of charge, conservation laws of energy, conservation laws of momentum, and that will decide whether any process can happen or not. So now let's understand its kinematics. Suppose an electron-positron pair is produced when the photon comes near or interact with the nucleus, and this nucleus is at rest initially. So, what is the energy conservation law? Energy conservation law tells us that initial energy is the final energy. Now, initial energy is the photon energy, because initially the nucleus is assumed to be at rest. So, the incident photon energy is h cross omega, and it will be equal to the final energy, and the final production, that the generation of two pair particles, that is one electron, another is positron, and some recoil velocity of the nucleus. Okay, so E minus is the energy, kinetic energy of the total energy of the electron. E plus is the total energy of the positron, and En or Kn is the recoil energy of the nucleus. So total energy of the electron is rest mass energy plus its kinetic energy. Total energy of positron is rest mass energy plus its kinetic energy. Rest mass energy for both electron and positron are same, because they are having same masses. So Me, for both the cases, Me into c square, and the kinetic energy for electron is Ke minus, and kinetic energy for positron is Ke plus. So if we assume that Kn, the recoil velocity of the nucleus, or kinetic energy of the nucleus, is very much less, then we can neglect this, and this is a good approximation. Okay, so then the final energy will become 2 into Ma into c square plus kinetic energy of the electron plus kinetic energy of the positron. So look here, we have defined our parameters, that 2 me c square is the sum of the rest masses of the electron and positron. Ke minus, Ke plus are the kinetic energies of the electron and positron. En or Kn is the recoil energy of the nucleus, and it can be neglected. Now the rest mass energy of electron or positron is me c square, and that is 511 kilo electron volt. So 2 into mEc square will become 2 into 511 kilo electron volt, and that gives 1.022 mega electron volt. So the incident photon energy H cross omega, and the final energy is 1.022 mega electron volt plus kinetic energy of the electron plus kinetic energy of the positron. If we are thinking that after production, after generating pairs of positron and electron, the kinetic energies are zero, then the energy of the incident radiation, electromagnetic radiation or incident photon is at least equal to 1.022. Or we can also tell as the pair production will only be possible if the photon energy at least have 1.022 mega electron volt. If so, this much energy is needed, at least needed for production of pairs. And our given question is the photon, incident photon or incident EM radiation has energy 1.1 mega electron volt. So this radiation have much more energy than the required energy for the producing or generating the pairs. So yes, it can generate a electron and positron pair. Now some more conclusions we should draw, and we should know some more physics about pair production, and we should know the pair annihilation process also, and we will compare the energies that is required for the photoelectric effect, that is required for the Compton effect, and that is required for the pair production. So the conclusions are, more conclusions are that photons cannot produce an electron or positron alone, because photon charge is chargeless, there is no charge in photon. So if electron or positron alone can be generated, then there will be the violation of charge conservation. So it cannot produce a electron and positron alone, it can produce the pair of electron and positron. If someone asks you why the both pairs are why is there any possibility from photon you are getting electron alone or positron alone or some other charged particles, you will surely tell no, it cannot, because it will violate the charge conservation law. And the next thing is, a massive object such as the nucleus must participate in the process to take away some of the photon's momentum to make the momentum conservation law valid. We should know some more history and some more physics about the pair production. First of all, this phenomena is another phenomena that only this can be described by the corpuscular properties of light, because it will account the photon property of the light, not the electromagnetic wave property. And another thing is that the non-relativistic quantum mechanics cannot explain the pair production process. And this non-relativistic quantum mechanics that was given by Schrodinger and Heisenberg was unable to discuss or describe the process. And it was only successful, the phenomena describing the phenomena was successful by Dirac, because he gave the relativistic quantum theory in 1928, and he predicted that if there is electron, there should be an antiparticle, and that should be of equal mass and opposite charge, and he named this particle as positron. So this particle, defined as the antiparticle of the electron, was predicted to have the same mass as the electron and an equal but opposite means positive charge. Now the pair production phenomena can only be described considering the relativistic quantum mechanics. Now when it was experimentally verified, the experimentally verification was done in 1932 by Anderson, and he discovered positron, for which he got Nobel Prize in physics. How he discovered that thing? He was studying the trails left by cosmic rays in a cloud chamber, okay, and cosmic rays are high energy electromagnetic radiation like gamma rays. So the when high frequency electromagnetic radiation passes through a foil, individual photons of this radiation disappear by producing a pair of particles consisting of an electron and a positron. So from photon he was getting electron and positron, and surely this process is pair production process. Now we should know the reverse process of pair production, that is called pair annihilation. And when the electron and positron collide with each other, they annihilate, and then they give rise to electromagnetic radiation. That is, from electron and positron we can get photon. And Also, from this process, we can explain why the positron do not long last in nature. Why? Because whenever a positron is generated in a pair production process, it will pass through the matter and it will make collision with the electrons inside the matter, and so it will be annihilated and it will generate photon. So this is it has a lifetime of, positron has a mean lifetime of about 10 to the power minus 10 second. Okay. Look here, this is the schematic diagram of pair annihilation process. Here positron is colliding with electron and it can generate or it can produce photons. Now, what is the success of this pair production or pair annihilation process? Because it is a direct consequence of mass energy equation of Einstein, that is E equals to mc square. What does it mean? You should understand physically that from energy we can get mass, or from mass we can get energy. So the pair production, actually the gamma ray, that is energy, it is producing electron and positron pair, and electron positron both have masses. So from energy we can get mass, and the annihilation process also, from mass we can get energy. So this is a direct consequence of Einstein mass energy equivalence. Now we should know when the photoelectric effect will dominate, when the Compton scattering will dominate, and when the pair production will dominate. This all the light matter interaction. So photoelectric effect will dominate in the order of this amount. If it is the energy is plotted MAV order, and this is the atomic number plot of the absorber, okay, the medium, and this is the incident energy. So first the photoelectric effect dominate in the first range of energies, with it needs some few energies because it will excite the lower bound state and the lower bound electron, and this lowest bound electron, that is the outermost electron or free electrons in case of metal, will get out of the metal, and then we can get the photoelectric current, and then Compton scattering will dominate, and Compton scattering is the scattering of photons with the bound electron, and this scattering of photon will give some energy to the electron, and electron will require some kinetic energy, and photon, incident photon, will give some energy, so it will have lower energy. So this is the range of Compton, and for pair production we need at least 1.01 mega electron volt. So it is the highest energy occurring process. So if you understand this video, please don't forget to like this video, don't forget to share with your friends. Also don't forget to subscribe this channel for more beautiful videos and for more useful videos in physics. And also if you want to help us, you can help us by clicking the link given in the description box.